Yes. Hello, Priyanka. Good to have you back. And have you started with any of the courses on the portal? I guess Sonalika has asked you to go through the BioML course, right? Or the art coding course. Have you started with those? Hello, Krishna Kumar. It's good to have you here. Can you let me know what is your background as well? Are you from a biology background or from a computer science background? All right, perfect. And do you have any specific research interests with respect to health informatics? All right, perfect. And what about rest of the participants? Can you let me know about your educational background as well? Are you from a biology background or from a computer science background? I'm curious to know. Can you let me know, like, why have you guys joined the program? Do you have any specific reason? Are you trying to learn machine learning, or what is your purpose or motive behind joining the program? Okay, so Tariq Bashir says he has completed masters in public health. He is doing masters in public health from Hyderabad Central University, and Krishna Kumar has joined the program for mentor guidance research. All right, perfect. Tariq Bashir, can you also let me know, like, why have you joined today's program? Do you have any specific research interest in mind? Okay, he says, I would like to explore this emerging vertical in the field of public health. All right. And have you started with any of the courses on Omics Logic Learn portal, or are you here for the first time? Okay. So I'll walk you through a brief demo on how you can sign up on the portal and how you can take a look at various courses that are there so that you can carry along with the program based on your research interest. And I can see that a couple more of participants have joined. It would be great if you could also introduce yourselves in the chat box. And Mukesh Kumar says he's interested for data science, machine learning, and I am non-tech background from accounts finance and did BCom, MBA in Python training done and data science. Now interested for machine learning in healthcare. That's very impressive. I'm curious to know, like, what made you interested in this field of machine learning for healthcare? I can see that you have a diverse range of background from accounts, finance. I'm curious to know what made you interested in this field. You are interested because of the many opportunities in healthcare. And I can see that we also have many familiar participants among us, Nakul Bora, Tanmoy. I can see that you guys have joined today's meeting as well. Can you also let me know what made you into machine learning for health informatics? Okay, Tanmoy says he is interested in research on DNA-specific virus that can counterattack against potential microorganisms. So he is interested in virology. What about the rest of you guys? All right. So meanwhile, other participants join. I'll quickly start with a brief introduction. So hello, everyone. A very warm greeting to one and all. My name is Srigauri Krishnakumar, and I would like to welcome you all for the very first session on machine learning for health informatics program. For those of you who are new to the program, the machine learning for health informatics has been designed for anyone who is interested to learn about applications of health informatics, machine learning, and artificial intelligence to help address global health problems. And in today's session, we'll be covering topics on AI in transforming healthcare, investments in AI for healthcare, how data science is transforming healthcare, challenges in health informatics, predictive model workflow, multimodal approach for precision medicine, and finally, we'll be ending with a Q&A discussion with the expert, wherein we are joined by Dr. Jit Sarkar, who is the Senior Bioinformatics Scientist at LOS Data. Also, before we begin with today's session, let me also take a brief moment to introduce you to the team behind the program. We are a US-based bioinformatics company who is working with multiple academic and commercial collaborators to develop easy-to-use analytical tools, and our mission is to make bioinformatics more accessible. And as a part of the program, students will have access to the Omics Logic training that has been completed by over 24,000 participants from 187 countries in over 300 workshops. And this training has been completed by participants in 6 different specialization tracks that includes oncology, infectious diseases, precision medicine, neuroscience, data science, and even comprehensive training on omics data analysis. And here you will be also getting access to several of the resources on Omics Logic. Omics Logic is a portal for practical and theoretical learning of bioinformatics. It takes a combination of training modules, data analysis tools, curated project data set, and interactive sessions with mentors to give the student a clear path of the Bloom's taxonomy pyramid. And no matter what the user's initial experience with bioinformatics is, Omics Logic is going to be a very useful tool for gaining a baseline knowledge of the theory behind bioinformatics, analysis of large data sets, and introduction to basic coding languages like R and Python, or even beginning a data analysis project. And as part of the program, you'll also get access to several of the Omics Logic courses that consist of courses on bioinformatics, precision medicine, multi-omics that consist of genomics, transcriptomics, epigenomics, and data science that consist of using R and Python, as well as cheminformatics, and also several example projects which you could learn from and replicate for your research work. Users will also be given directions to access the T-Bioinfo platform for bioinformatic processing and analysis of data. And different stages of analysis will be performed in different sections on this multi-omics platform, as you can see in the presentation. So now, to view the various courses and example projects, let us first sign up on the Omics Logic Learn portal. I can see that several of the participants have already joined, have already logged in on the portal. But for those participants who are new, let me take a brief moment to show you how you can sign up on the portal and navigate through the various courses that are there. So I've pasted the link for signing up on the portal in the chat box. So please visit the link and I will walk you through. So for those participants who are new, you can simply click on the create an account option that you see here, and you can simply sign up by entering your name, email ID, password, or you can also log in using any of your social media accounts. And for those participants who already have an account on the portal, you can simply click on login now option and simply click on sign in. So if you are facing any technical issues, let me know in the chat and I'll be happy to guide you on how to sign up on the portal. I'll pause for a couple of seconds so that the participants can sign up. And once you have signed up, please put a yes in the chat box so that I know I can proceed ahead. And if you have already signed up on the portal also, you can put a yes so that I can get a fair amount of idea of who have signed up and who have not. Has everyone signed up? Please put a yes in the chat box. All right, so I'm going to proceed ahead. So if you're having any queries, you can let me know. So once you sign in on the portal, you'll be able to see the various courses and example projects that are there. And to navigate through the various courses, you can simply enter the keyword that you're looking for. For instance, most of the participants will be interested in machine learning. You can simply enter the term that will show you the various courses and example projects that makes use of the machine learning concept. So now coming to one of the important part is you need to update your account once you sign up on the portal. So how do you do that? You can simply click on the icon that says profile, and here you will be asked to upload your profile image. You can edit your bio, you can edit your name. Please make sure that it should be in proper capitalization. And you can also link your social media handle as well, such as in my case, I've linked my LinkedIn account at So once done, click on update and that will get updated. So, and the next part is the activity tab, where the program mentor and the community manager will be tracking your learning progress. And once you start taking up any of the courses, that will be displayed under the courses tab. And once you complete a research project and publish it on our portal, that will be displayed under the projects tab. And once you enroll for any of the programs, such as machine learning for health informatics, that will be displayed under the programs tab. And finally, once you complete the required quizzes, assignments, and activities, you'll be able to receive your certificates under the certificates tab. So if the participants have no further queries, let us move on to the next exciting part of today's webinar, wherein we are joined by Dr. Jit Sarkar. For those of you who are joining for the first time, let me introduce you to the program mentor. Dr. Jit Sarkar is a physician scientist with a keen interest in data analytics and precision medicine. He is passionate about finding meaning out of biomedical data and leveraging them for better clinical outcomes. Currently working as a senior bioinformatics scientist at Elucidator, I'm sure we'll be able to learn a lot from today's session. And with that, I'd like to pass on the stage to Dr. Sarkar. Over to you, sir.
Hello.
Yes, sir.
Thanks, Grigori, for your kind words. So, as introduced, this is the first session of the course, which has been named as Health Informatics. And so today we will just briefly touch upon the background, and I will give the introduction of the entire course and what are the key things which we will be covering in all the 12 sessions. So let me share my screen. Is my screen visible?
Yes, sir.
Yes, we can see your screen.
Yes. So hello once again. So today we will be covering the overview of the course, which has been named as Machine Learning in Health Informatics. So as you know, it's really a booming field right now. It's right now in a very embryonic stage. There are resources, there are scope in the coming days, but the field has not that much matured. So that's why we we conceived the idea of introducing the young generation, the graduates, and some PhD students who are currently enrolled PhD, or those who are in the early career stage of their career, to this particular course. So I will start about a brief introduction about myself. So this is a brief a glimpse of my journey. So I basically come from a clinical background. I was majorly involved in healthcare delivery during my graduation and during my clinical residency. So from that time only, because I had a knack of uh, quantitative sciences, so from there I shifted gradually to the clinical research. Now, as my responsibilities of healthcare delivery went down, the healthcare research part went up. And for the last 6 years, I have been working in the domain of informatics, mainly covering bioinformatics and healthcare informatics. So this is my journey. So it has been 6 years in the academia. By academia, I mean undergrad and postgrad. Then in research in my doctoral degree for 5 years, and for the last 2 years in industry. So mainly I am involved in informatics and data analytics in using biotech data and healthcare data for the last 6 to 7 years. Okay. So this is actually the three big sections which gives an overview of my career. So in academia, I am majorly trained on biology and medicine, the basics of biology and medicine, health and disease. So how do we define health? What is health? What is disease? Also clinical approach to medicine and public health approach to medicine. So these are all mainly not quantitative sciences, majorly qualitative sciences with some guideline based or rule based things which we have to learn. It also gives a very first hand understanding of the biology and medicine. It clears the concepts, and that's how academia actually helps and helped me. During my research, I gradually shifted to the quantitative sciences. So where we quantify biology, we quantify medicine, we quantify health, we quantify disease. And after that, once we quantify disease, then you can predict disease. We can predict health. So this quantitative approach to medicine is what I learned during my research career. But again, it was mostly driven by academic interests and so on. Now, for the last 2 years, I actually work on industry solutions. Now, where we actually bridge the academic expertise and research to build a product or a solution. Now, this is where actually we translate the knowledge and give it back to the community, to the society, to the population. So, and actually industry scale healthcare data sets, these are very, very huge. They need lots of computation. So you also need to have the expertise of computational biology. You need to know the basics of programming. You need to know some advanced level of programming also. And that's a big requirement, which we will also cover in this course. So we will give in the last 4-6 sessions, we will cover some hands-on exercise where we will discuss about the 2 case studies, and we will walk you through the entire code and the notebook and explain those things, and just to give a hands-on practical feeling. Now to start with, so AI in healthcare, it's actually right now it's not that much of a unknown thing. People talk about it, people write about it, and we come across news in the media, in the newspapers, in websites, browsers. But if you see, it has majorly increased from to around 6 or 7 years back. So this is from where the sort of a disruption occurred, where people started to use AI and machine learning and data science to transform healthcare. Now, if you notice the journey has been phenomenal. So there has been multifold increase in AI in transforming healthcare, and there are lots and lots of places where AI is being used today, and it's a very diverse field. It's a very chaotic field, healthcare and healthcare data. But again, the data amount is going to increase exponentially. And as the data amount increases, as the computational power increases of the hardware and software, hence the requirement of trained resources who are well comfortable with handling healthcare data in building models. There is an enormous scope of this particular field. So there are so to just to give an overview, I have just broken them into six big fields, and this actually is a survey done by Health and McKinsey, and they have just identified the resource requirement which is going to emerge in the coming future. So we will be requiring chronic care management because, as you know, there's something called demographic transition. So there's something called the pyramid. So there is a young generation, there is a adult generation, there is an old generation. So now what is happening? There is a demographic transition where the number of the geriatric population of the adult and old population is increasing gradually. And with this adult population, geriatric population, is there something called increased life expectancy. So increased life expectancy with a huge burden of geriatric population will generate the need of chronic care management. And so this is a and chronic care has lots of data, and all these data can be used to build models and so on. Now, next is self-care. So self-care again comes with chronic care, and self-care is majorly for prevention and for wellness. And then is triage and diagnosis. So we know that the number of patients, the number of the hospital bed accommodation and the requirement, those are increasing very rapidly. And there we have to do some patient stratification. We have to do some triage and diagnosis. And that's where we need to merge multiple types of data. We need to merge healthcare data, lab data, then data from pharmacy records, data from genetic records, and to build some triage mechanism, some stratification mechanism. Next is diagnostics. So by diagnostics, we mean actually how do we diagnose a disease via some kits, via some X-ray images. So these are also increasing because nowadays everybody likes to do a diagnostic, and actually diagnosis is a much more objective thing compared to a subjective decision. And so we also have a great emphasis on automating diagnosis to give automated reports. So nowadays ECG already comes with an automated report. Now X-rays will also come with an automated report. Now those reports have to be verified by the doctor or the physician, but it would give a starting point and would help in triaging, in making the process much more fast. And of course, clinical decision support. This can be in ICU care, in intensive care unit. You can recommend some drugs for particular diseases with some comorbid conditions. So it's a very complex area, clinical decision support. And care delivery is, how do we coordinate care? So for healthcare, we have to coordinate between the nurses and physicians and the paramedics and the pharmacy person and maybe the relatives. So how do we coordinate the care? So all these things actually in bits and pieces, they are the bits and pieces of the entire healthcare puzzle. And informatics is slowly growing in this field, and it will actually show its potential once the resources and everything becomes much more available. So if we talk about the investments in AI for healthcare, so here I have just shown the top 50 companies and the amount of revenue which they have generated just for introducing AI in healthcare. And you can see there is a lots of almost 8.5 billion of venture capitalist funding in 50 best funded AI companies. And the top 50 has, so the top 50 has reported close to 8.5 billion, and the top 10 has almost close to 5 billion. And nowadays, big companies like Google and Amazon, they're also introducing their foot into the domain of AI in healthcare. So now, how data science can transform healthcare as such? So the first thing which comes to our mind when we talk about health is patient, and so we have to cater much more precise and much more appropriate patient care. So suppose for a patient can have a management date, uh, have an appointment date, have a visit date. Now there is something called when is the pending appointment. So what should be the next visit date? Now this date actually doctors prescribe on the basis of some, suppose 1 month, 2 month, 3 months. There are some rules, but can these next visit date can be more precise? Depending on the historical records, can we predict that this patient actually needs a visit after 25 days, or after 60 days, or after 30 days? And accordingly, if we can distribute and coordinate all the patients for a particular healthcare system, for a nursing home, or for a hospital, or for a city, or for a village, so that the appointment times also decreases and the visits are very coordinatedly happen, so as to ensure that each patient get the maximal benefit of care. Now, next is precise diagnostics. So again, precise diagnostics. So one person can have diabetes or hypertension. Now that person can also have some genetic genetic perturbation, some mutation, and so it may be the case that that person one drug would not be helping that person, because that person has that particular genetic mutation. So if we have the knowledge of that genetic mutation, and if we can incorporate that in the clinical predictive decision making, then we can build much more precise diagnostics and much more precise treatment for the particular person. So there are some known genetic mutations actually which make sense. So there is something called SGLT inhibitor, and so these are actually some specific inhibitors which block one receptor and help in treatment of diabetes. Now that receptor, the gene which translates that receptor, that gene might be mutated in a particular section. Now for those sections, that drug may not be effective at that much level. So that person might need a higher dose compared to any other person. So you can also make the dosage much more precise compared to a very sort of a very high level dosage which we actually do. Suppose 10 milligrams, 20 milligram, 30 milligrams. So we can maybe do much more, 12.5 milligram or 18.75 milligrams sort of thing. So these are all actually right now not in the air, but people are working very hard. Big companies are hitting their heads all day for this discovery. But this is how the things are going to be in the coming days. Now, disease prevention. Is a very important topic, and the module is called as rising risk prediction. So, rising risk prediction is a very big topic, and if you go and Google rising risk prediction, you will just find out lots of deep learning models and graph network models and regression models which have explored millions and billions of records. It's a really huge data, 3 GB, 4 GB, 10 GB files of maybe 6 billion persons who have been followed for 10 years. All the diseases, all the lab investigations, unstructured clinical notes, images, ultrasound, CT scans, everything is there. And from there, you have to predict that this person who is suffering from disease A, disease B, disease C is going to have developed a disease D in 30 days or 60 days or 1 year. Now, if you can predict this particular thing, then you can also prevent that disease via providing some preventive modifications, some solutions, some management like that. So disease prevention is a very important thing, and it is more important given the lack of healthcare resource, and because once the disease sets in, then the healthcare cost just uh, it it grows exponentially. So if we can prevent a disease, it's the best solution in terms of care, in terms of costs, and in terms of health. And if we just see that the disease at a much later stage, then the cost is high, the care is not that much good, and the health burden on that particular person and society is also very high. So that's why early disease prediction prevention is a much important topic. So, and just to mention, we are shifting towards value-based medicine. So value-based medicine actually emphasizes that if you are treating a patient, you should be able to show me the outcome. That I have treated this 1,000 patients, and the outcome is that they are having out of them I have prevented, suppose, 10% of people from getting amputation. I have prevented the hospital admission rate by 30%. So these figures, these real and very specific figures, 30%, 10%. So these things are important in the coming days. And actually, insurance companies will also be paid based on their will also pay the health providers based on that particular value-based care. Now, patient triage, I have already told that. So when you are having a big hospital setup with many patients who are in the many domain of suffering from multiple diseases, then you have to stratify those patients, and this is what we called as patient triage or risk stratification. Because in that case, you can instead of giving the similar care to all the patients, you can identify that out of my 100 patients, these 15 patients are of high priority and they have a high risk. So I should give more care to these 15 patients. So this is how we can do patient triage and then services. Then imaging and diagnostic, I already have told that nowadays imaging, ECGs, they all come with some automated solutions. So we can do simple predictions from these images and diagnostics and help. And this is how we can explore data science in the domain of healthcare. So next is business process and management. So healthcare is actually it's a big management thing. So there are lots of people. There are administrators, there are physicians, nurses, then paramedics, then maybe the ambulance drivers, and there are lots of hospital cleaners and all the staff. Okay, and there's already something called automation and business process management and automating certain things, and there also it's a very important role of data science to play there. Now claims administration, now claims handling claim record, now identifying fraudulent claims, identifying fraudulent patients. So this is also, it's sort of a credit card. So right, just the same logic how we we identify credit card fraud transactions. So because claims industry is a big industry, it's a very, very big industry, and so identifying fraudulent claims, it's a very big task in healthcare. Customer churn, so we can actually see that in which season, in which location, from which location which specific patients are coming to our to the hospital, and what is the footfall, and how it goes up and comes down, and how we can increase retention, how we can provide more care, maybe decrease the risk of readmission, and all those things. Chatbot, it's again, so right now, again, with the increase of healthcare demand and not that much of increase in the healthcare resources, I mean, physicians and nurses, there should be some automated chatbot like solutions who can actually provide a very high level or a very preliminary level of engagement with the patient. And last of all, business insights. Now, the last thing, and probably the most famous or thing among students or biotech companies are pharmaceuticals. And so drug discovery. Now, in this context, drug discovery is important, but in the context of healthcare, in oncology, generally we don't find many patients responding to a particular drug in any cancer. So the idea was to identify a precise mutation for those particular patients, and to design a specific drug which can treat the patient. So instead of just a sort of a blanket therapy where I give a single drug to all patients, I will try to identify the type of mutation or mutations or genetic perturbations, and then I will try to provide design a very specific drug for that particular mutations, and that will help me provide much more precise treatment. Planning logistics and improvement in clinical trials. So clinical trial is a very long journey. So it takes, suppose, phase 1, then phase 2, phase 3, then phase 3B, phase 4, phase 5. It's a very long journey. So for the drug to be discovered and the drug to come to the market, it's a very long journey. And people are trying to make it short so as to patients can take the benefit much more at a much more earlier stage. And this improvement of clinical trials, we can also do some mock trials. We can do some trials on the available data. We don't need to redo each and every trial for every condition, and that's where clinical trial data analytics is very important, which can also help the biotech and pharmaceutical industry. So this is the very three big pillars which I just explained. There can be much more specific pillars which you may come across. Now the challenges in health informatics. So we have talked about the scope, that is the how is data science going to inform and going to influence the healthcare industry. What are the various big high level scope of data science, patient care, then business and pharmaceuticals and automation. Then now we talk into the challenges. Now healthcare data is actually so healthcare data is anything. So it can be, so you go to a doctor and the doctor writes a prescription. It's a handwritten clinical note. So it's a healthcare data. And this data still now in the developing countries, and there are lots, still now people write handwritten notes, and those actually stay in silos in a very isolated condition, either in a room or in the patient's cupboard or in the file. And those data we can't exploit that data. We can't. So the potential is actually compromised of that data. So, and it's a big challenge. Even if we extract that data using OCR, even if the clinical notes, if we convert the clinical notes into digital clinical notes, still it is unstructured. So it has no tabular structure. It has no row and columns or key or values. It is very unstructured, and we need to parse it via using some natural language processing tasks. Now this is not very easy right now, but I guess with the advancement of NLP, NLP procedures. Now, ChatGPT has also come with the advancement of BERT models, transformer-based models, and now the big shots are coming into this domain. Healthcare might be the next target of NLP-based based analytics for data extraction. So this is called data quality and infrastructure. So data quality means, so now there's clinical notes which lie, suppose, in the software or in your house in a file. There is some lab reports which are in the lab database. There are some pharmacy reports which are in the pharmacy database. There are some medicine reports in the outdoor, some in the indoor. Some data is your social demographic data, which lies somewhere in the National Family Health Survey portal or whatever portal you are having. So there are lots of different databases. The data is actually spread across multiple databases, and you have to connect all of them to find the real value of this entire data. And you also have social network data, which actually tells about your mental health and your mental condition. So lots of data scattered here and there, and under different jurisdictions, under different departments. So you have to coordinate the entire thing and get the data and then clean it and structure it, and only then will you be able to use it for some predictive modeling. And it's a huge task. It's an enormous task. You have no idea how the data cleaning is a very, very important task in health informatics. So data and the data quality is also a part, because the data quality might not be the same across all particular vendors and all particular providers and all particular departments. So lack of data quality and lack of fairness, which we called findability, then interoperability, reusability. So lack of fairness and lack of data quality. So the solution, what we can tell, so right now what we do is we build clinical registries. So actually, the problem is that healthcare data is not captured with the intention to capture healthcare data. Data is captured for as a sub process of care delivery. So the nurses deliver care, and in the process of care, they capture some data. And that's why the data capture mechanism is not so streamlined, not so structured. So what is the solution? To build clinical registries. Actually, clinical registries are built where you provide care, but you also have a very high priority of capturing structured data, and which will be fed for scientific evaluation and research. And we can also develop a proper ontology for this structuring of unstructured data. So there is a very huge database called UMLS, Unified Medical Language System, and it contains lots and lots of ontology and mapping to this and this and that. And that actually is used by most of the companies to do this data verification. Now, next is the compliance. Now, healthcare data is very private. Okay, so so you can't very easily get hold of healthcare data like any other business data. Okay, so compliance and governance is very important. There are already complex regulatory guidelines for healthcare data storage. So anybody can't store data. Anybody can't transform your data to any facility very easily. And HIPAA guideline is in the US, then GDPR is in the Europe. So there are particular guidelines, and the storage facility has to be HIPAA compliant and GDPR compliant. Only then they will be able to store it. And the solution to be compliant, and there's a very complex solution which is called federated learning. And actually it exploits, so it's a very brand new concept, not brand new, but it hasn't been so successfully implemented right now. So where the data will reside in the particular nursing home or hospital or the healthcare space, and the model will also be developed and run from that data in the local manner. Only the model parameters will be shifted in a central repository, not the data, just the model parameters. And there will be a to and fro journey of the model parameters. So the parameters would be collected from multiple hospitals. Then there would be aggregation and then again a redistribution. So the data won't reside in any central server. The data would be residing locally in all the hospitals. The predictive models would be running locally in all the hospitals, but the parameter generation and testing and aggregation and redistribution would be just uh, occurring in the central repository. So I would suggest everybody just to give a high level, just go through a high level understanding of predictive learning, and it's a very uh, a new concept. It's a very interesting concept, and people may get much more interested in it. And lastly, even if we have data quality maintained, even if we have data compliance issues solved, then there is data science skill lack. So we actually lack lots of data literacy. So the healthcare workers, the nurses, physicians, they are not at all data literate or computationally very expert. So they have no idea of how to explore the data, how to use the data for their own purpose, and like, okay. And the other way, we also have much more skilled data analysts, but they don't understand the complexity of healthcare domain. So there we need to form a bridge. So we need the healthcare workers to be more learned in and data literate, or we need skilled data analysts who have the understanding of healthcare domain complexity. And this is where we need knowledge and skill set of various different data sources and types for health informatics. And this is where actually the course has been conceived and formulated for. Now, use cases. I will just go touch upon the use cases which form under the big umbrella of health informatics. So health informatics can start with predictive analytics. So a patient having certain diseases, that patient might have a sudden cardiac attack, might have a fall, might have a chance of getting hospitalized. So if we can predict that event prior to its happening, and if you can put that particular person on high risk radar, maybe put that person on as a high alert patient, and accordingly monitor them, so that the event doesn't occur, or even if the event occurs, we can very quickly and swiftly move that person to a particular facility and give very urgent and proactive care to that particular person. So this is called predictive analytics, and that this can be multiple things. We will touch upon one particular use case in this particular course, but there can be multiple use cases in this particular domain. Cluster identification. So in healthcare, we have lots of patients, we have lots of physicians. So if we can have a data science and we have the data that which physician has seen which particular patient in which date, and what was the outcome. So from there we can cluster physicians, that this particular cluster of physicians are very trained in treating migraine, or this particular cluster of physicians are very trained in treating epilepsy. And this cluster actually treat type 2 diabetes very good for this particular age group. So we can determine cluster of physicians from the healthcare data. In the same manner, we may have some data of the patients, and we can tell that this particular age group of patients who are majorly male and who have a very peculiar type of dietary pattern more commonly present with disease A, B, C, and D. So let's modify their diet in a very precise way. On the other cluster might have a different pattern of health problems. So one cluster can be having mental health problem with diabetes. One cluster diabetes and hypertension. one cluster having another diabetes with hypothyroid, and we can actually detect those clusters, and maybe we can cater much more specific medication accordingly. Now, time series analysis. So nowadays, all of us are actually we use Fitbits, we use wearables, so we can just stream the live stream the data coming from the Fitbit, the heart rate, blood pressure, and all those things. And the heart rate goes up when we are having some exercise. The heart rate also goes up when we are having some problem pathologically. So if we can detect that pathological condition from time series data, and again, so once we detect, once we predict that this person is going to have an incident heart attack, or an incident acute asthmatic attack, then we can either prevent it, or we can or we can coordinate the resources in such a way that proper care is rendered at a much earlier stage, and the patient is not ignored until a very late stage. So you can use time series models for that particular purpose. We can do image analytics, where we can automate CT scan reports, X-ray reports, MRI reports, and even video. There are also colonoscopy, endoscopy, and USG, which are actually video files. We can also classify those video files for this purpose. We can detect handwritten clinical notes, and we can apply NLP-based rules and models to extract data, structure them, and then find insights from that particular. So we can take, suppose, 1,000 prescriptions from one hospital and 1,000 from other hospital, maybe at 2 different months of the year. We can do the extraction, and we can see that which is the most commonly prescribed drug in that hospital in that month, which are the most commonly co-occurring conditions for a particular age group, which is the most commonly which is the most common month for the increase of dengue in a particular region. So you can do multiple types of analytics if we can explore that particular field using NLP and all. And we can, of course, customize those models. We can combine predictive analytics. We can combine image with handwritten and time series to do a prediction. And there are lots of scopes for this. So just to give 3 examples. So as I just told before also, we can subtype a particular cancer, and we can identify specific gene perturbations or gene mutations for a cancer group, and we can cater a very specific precise therapy. We can detect and classify tumors from X-ray or CT scan or MRI images. From mental health, because mental health is actually a very chronic condition. Mental health conditions like anxiety, depression, which lead to suicide or severe depression, when the person gives up everything, he has less appetite, doesn't eat, doesn't sleep, loses interest in job and relationships and friends and occupation and profession. So these mental health conditions we can predict from the social network posts, from different facial expressions. There are lots of opportunities. So we can the facial expression, the facial gauge, the posts which they are doing in the social network, we can analyze them to predict. And even the voice quality, the voice quality over the phone, we can just exploit to do a mental health prediction. So there are lots of possible. Just wanted to give you a very diverse sort of explanation or exposure here. Now, how does a predictive model actually look like? So now, as you already know, there would be different types of sources. There would be EHRs, which are electronic health records, digital records, unstructured records majorly. There would be wireless wearables, so Fitbits and remote patient monitoring devices, Apple Fitbits and Samsung Fitbits. Medical devices that can be SpO2 monitor, that can be other ECG, home-based ECG monitors. Clinical notes can be handwritten. Pharmacy records what the drug the patient has received for the last 1 year, 2 year, 3 year in the pharmacy in the database. Lab investigations for all the tests and the values. publicly available database which tells you that suppose this patient comes from a particular state or for a particular county, and that county has a literacy rate of that much percent, that county has a dietary pattern of this. So publicly available databases can also be used for that particular purpose. And you can also ask, send regular surveys that how is your mood, how are you feeling to the particular person, and they can also reply, and we can just collect information. So all the information can be clubbed together in a database, of course complying with regulations. And this is a very big task, and this is called as data preparation. So once we do the data preparation, we can again explore the features. We can explore the social demographic features. We can explore the comorbidities. We can explore the lifestyle habits, the self-taken surveys, the real-time vitals from the Fitbits. So we can explore all the different groups of features, and then we can feature engineer these particular feature groups, and then we can feed them into a training, split them into training and validation, and we can feed them into a machine learning model. Now, this machine learning model will receive the training set, and it will adjust the parameters of the model. And there is very intricate mathematics in this particular modeling, and that also differs from one to other model. And this machine learning model will be tested, will be cross-validated, and it will arrive to a particular accuracy and sensitivity and specificity. We will talk about all these things more specifically in the hands-on case studies. Now, this model we can use to predict length of stay prediction. Suppose a patient gets hospitalized. When the patient gets hospitalized, we take all the information and we predict that this patient is going to stay for 10 days, or this for 5 days, or this for 7 days, or this for 2 days. So we can do this prediction. We can predict chronic disease risk. So this a patient suffering from these 5 diseases have a risk of developing a 6th disease in the coming 6 months. So let's prevent that. We can just have some clinical decision. A patient gets released from the hospital. So what is the chance of that patient again getting readmitted? We can predict. Once a patient goes through a surgery, maybe a minor surgery, major surgery, what is the risk of developing post-operative complications? So if the patient is diabetic, if the surgical site has not healed within the first 6 hours, and if there is some pus coming out, and the patient already have some added comorbidity, so we can predict if the patient is having other post-op complications. We can predict vital parameters, that the patient is going to have an impending heart attack or an impending acute asthmatic attack from the vital parameters, and also mental health outcome prediction. So we can there can be lots and lots of other clinical outcomes. I just mentioned a few here, and we can also customize the model. Now, just to mention, in healthcare domain, there's something called false positive and false negative. So false positive means the model has told that this person has a disease, but the person doesn't have a disease. And false negative means the model has told the person is normal or healthy, but the person is actually not healthy. The person is unhealthy. Now, in healthcare, we always try to increase the false positivity at the expense of a reduced false negativity, because we don't want a person who is actually having the disease to be diagnosed as healthy. We can bear with a person who is healthy to be diagnosed as unhealthy, because then the person would be taken forward and screened, and then the person would be discovered as healthy. But if the model tells that the person is actually healthy, and so the false negative rate we always try to decrease, and when the false negative rate is decreased, generally the false positive rate actually increases. So in healthcare models, we always try to decrease the false negative rate at the cost of an increased false positive rate. So that's something just keep in mind. In healthcare, false negative rate should be minimized, even if the false positive rate is actually much more higher. That's not a big problem in healthcare. And now when the new data comes from this again root, it goes to the model and then does the prediction. And now the most important part, maybe in healthcare, is featured importance coding. So healthcare domain is actually where the physicians, the nurses, they also want some explanation. That why is this model predicting that this person will develop this particular three diseases? Why? Now this is something called interpretable AI. Now the model has to score some feature importance, has to go through some interpretable AI solution, which will tell that this model has predicted these three diseases for this new person because of this reason. So it will give an interpretation of the prediction, and that's very important for healthcare decision making. Now, I am almost the last slide, I guess. So just to introduce this approach to you all. So this is known as multimodal approach for precision medicine. So I guess I have covered it on multiple occasions during the entire presentation. So we have different type of records from a same patient, and you can do different predictions. And this is where we do multimodal data fusion. So we concatenate, we merge different data types across all the databases. And that goes into a data interconnection that increases the cost, the complexity, and invasiveness, of course. But that again helps in much more precise, helps to take much more range of features for the prediction. And we can also do multimodal interpretability and do some quantitative analysis. Then we can do supervised learning, unsupervised learning. We can do biomarker exploration, and we can translate all the models to practice. So it's a big journey, not so simple as I just told, but actually the healthcare industry is moving towards multimodal data fusion, where people are trying to use multimodal data to predict a particular clinical outcome. And this multimodal data ranges from unstructured clinical notes to time series data to genomics data to proteomics data to transcriptomics data to family history to the treatment received and everything. So this is actually going to be a very integrative field, and it will maybe translate into something called biomedical informatics, which will take bioinformatics as well as healthcare informatics. Going into biomedical informatics is what the field will emerge in the coming days by this name. So that being told, this was the last slide of mine, and so these are the models, and so we can develop models in the lab by using the data, claims data, omics data, structured data, image data, clinical notes. But actually, these models need to be validated. There has to be internal validation, external validation, prospective validation, because we need to see if actually in the prospective validation it is happening or not. Local testing, randomized control trial. So it's validity. Also the usability. So how use and how usable and how user friendly the model is. So we also have to develop a very cool interface, very usable interface, which can be accessed via a smartphone or maybe at max a tab, because not at all a laptop or a desktop, because which has to be usable by every healthcare worker. And also the utility, if incorporating that particular model is actually helping to decrease the risk of rate of admission, to decrease the morbidity and mortality. So we also have to prove the utility, and that also we can prove via some RCT, where we can randomly integrate one model to one particular arm and not integrate one into particular arm, and see how the utility comes out. And then only it will arrive to a clinical impact, and we can take the model to deployment and clinical decision making. And this is the big gap. This might look like a small gap, but this is a very, very, very big gap. And I guess we will be able to solve it in the coming days. So with that, I would like to end my talk today, and now I am open for questions.
Thank you so much, sir. So the participants have any queries, please share it in the chat and we'll be happy to answer. We have a query from Ziaul. He's asking how much does it cost for the all procedures for a patient? I'm pasting the query in the chat once.
Okay,
The query.
there are also some questions. There's one question by Chirag. So, okay. So, how much does it cost for all the procedures for a patient? Okay. So, this will again depend on the particular disease or the particular symptoms. So, this would be much. So, if we just want to do a very plain genomics of one particular patient, so the cost of doing a deep sequencing has reduced over the last 1 decade. It would have been close to 60 or 70,000 to get the entire genome profiled in INR. But right now, I guess it can be around 30 to 35,000 for a genome profiling. But again, it's not about the cost. It's not a blanket cost. It will again. So if we are studying, it's not very case specific. So if we are trying to predict that which diabetes patients will develop chronic kidney disease in the coming 2 years, then we have to do those tests. We have to design the study to include those tests which detect diabetes, which detect chronic kidney disease, and so forth. We can't. It's not possible to do every test for every patient. So it depends on the research question at large. Okay, so there's another, are the jobs in the field related to diagnostic and analysis of disease, or they include job type of data scientist or database formation like typical jobs? So I guess whatever you have mentioned in your message, everything is on your plate, can be on your plate. Okay, so I will tell you. So the first is database management. So the healthcare database management is a very specialized field. That's something which people having the expertise of DBMS and database management, maybe typical IT jobs they will be doing. Data scientist would, and then there's something called data transcription and data translation, medical transcriptionist. The person actually structures the clinical data, and the person is very well versed with clinical entities and clinical coding, and how to map one disease, how to map 6 different names to a single name, and in that way there's the role of the medical transcriptionist. And then there is the data scientist who will be applying models by taking all these structured data, and that scientist will also have to structure the data on his or her own part. And so that's the thing. So the healthcare data scientist is what might be the um, top of the pyramid, but I guess it would fall under the purview of any IT solution which has solution architect, a database, a data structuring team, and a data prediction team. So it will operate more of like an IT solution actually. But the problems would be much more data science, healthcare specific. So you would also need some healthcare domain expert, some clinical domain expert who will provide you the clinical outlook. And then there's hello, thank you. Healthcare model where post-treatment, post-operative care is included. Post-treatment, do we make any assessment of those who have been released from the healthcare facilities after a month or few? This is to see at least if they were dissatisfied or this can be done. So when the person is released from a particular facility, then we should be having a prediction of the readmission risk in the coming 30 days, and the assessment of the post-operative complications that person might develop in the coming 30 days. And also the level of satisfaction, this also we can detect via some surveys, where that person will be doing some scoring, and then we can again increase the patient compliance to the particular facility. But again, these things are not at all very operating right now, might be in bits and pieces for one or two facilities. The entire thing is actually in discussion and in trial mode, and people are trying from the academia. So it's not, again, it's very embryonic. It's very, very embryonic actually. So that's where the potential and opportunity lies. Specific AI techniques that can be used for better diagnosis and prognosis in the lab, and what is the cost effectivity of those? The cost effectivity is actually good. So specific AI techniques. So actually, healthcare data is something called non-independent data. So it's very dependent data. Suppose for one particular patient, for a particular visit, the patient receives some drugs, has some diagnosis, may receive some procedure, some operation or something. So, and that patient may have multiple visits. So the patient's data is interdependent on that particular patient. So in this case, deep learning based models, and there is one particular modeling technique which people are using, multi-health self-attention models. And these models are very much into the space right now. And again, the effectivity, because now the problem is, in order to integrate a healthcare AI model into the healthcare, you have to go through the RCT procedure. And actually, people are telling you have to get a FDA approval that this model is going to treat patients. Now, we haven't yet reached to that particular scale. So we call it as assisted solutions, which will assist the particular person. But days are coming that they will be going through a very wide scope and wide implementation. Thank you for explanation. How should a public health professional fit into healthcare informatics? Public health professional is actually public health is actually a lots of data. Just to tell you, I started my journey from public health data. So in India, there's something called National Family Health Survey. Not in India, so it's a part of a global program called Demographic and Health Survey, DHS. You can go to the DHS site. There are lots of data. Large files, 3 GB, 6 GB, 20 GB files. Okay, and so the entire population. And so I remember my first data set had 8 lakh rows and almost 5,000 columns. Okay, so it was very tough to open in a very small laptop. So and from there you can. So I have one paper which from that particular data. So there we identified type 2 diabetes clusters, and each cluster had a very specific dietary habit and a very specific anthropometry. And those clusters are actually, from there, we can detect those clusters, and given a new patient with diabetes comes, we should actually provide a very specific lifestyle modification for diabetes. So nowadays, we just give a very blanket. So anybody with diabetes, this is the recommendation. That shouldn't be the case. There are very specific forms of diabetes, and you have to provide the recommendation keeping in mind those specific forms. And so again, public health professional, I guess, will be having a very easy route or easy entry to healthcare informatics from that perspective. Okay. How could a university student do something in biomedical AI technique? So I'm not sure how could a university student means at which level. Is the person a BSc or MSc or PhD? Everybody is a university student. So to start with, you should start with one question, one data set. There are lots of publicly available data set. I will actually introduce you in the next session, I guess, to almost 30 publicly available repos, which are having more than 1 million of data sets, structured, unstructured, and whatnot. And you could just download all those are downloadable. Just download one or two of them and have your own question, and then you can implement it. Are there any success stories of using models? There are, and just to be very so just tell you this very upfront. So healthcare informatics, as you know, it's a very it's because healthcare data is very tightly regulated. It's very scarce. Anybody can't access healthcare data. So, and the healthcare models and the solutions are also very private. So in our company also, we build healthcare models. So the success depends. So success we can test internally. We might not use those model for clinical decision support, but that definitely the models help us to generate insights and to design or to the course of the company, and how should the insurance provider behave, how can we prevent these diseases, how can we provide more better quality of care to reduce risk of getting hospitalized, and thereby to reduce the healthcare costs. So this we can do, and this we actually do, but these are actually very private data sets, and so there are.
Are there any further questions, sir? I think most of them are direct messages to you.
There are no other questions I see here. So, I would just encourage you all that first to conceive one particular question. So, in healthcare, because it's like a forest. So if you go to a forest, you will be getting lots of trees, lots of species, lots of animals, and you might get confused. Okay. So if it's a forest, at least narrow down your search. That I would like to limit my search to these 4 species of plants and 5 species of animals. So just try to specifically design a question. Data is available. We will talk about the data, and I will show you that all those data repos, and how can we access those data, how can we structure the data. But first of all, we need to make the question more specific. So once we make the question, then of course, because if you don't come from healthcare background, even if you come from healthcare background, for one particular question, you need to have a sense of the healthcare problem. That if you work with diabetes, at least what is diabetes, what are the risk factors of diabetes. So very, very basic things that we can also guide you. You just need to know, because unless you have the knowledge of the disease, you can't build a model successfully, because you also need to interpret the model. And once you have the question in your mind, you get the data, then you go through some very basic level of disease understanding, then you start to explore the data, then you start to build the model, then test the model, then explain the model. So it's a very 4 steps: data exploration, data preparation, data exploration, model building, and model interpretation. So these 4 steps will actually cover everything, but you need to narrow down your particular clinical research question.
Thank you so much, sir, for the wonderful session. And now, for those participants who have not enrolled for the program yet, some of them have shared their email IDs in the chat box. Rest of them also, you can share me your email ID either through direct message. And also for the program details and registration costs, now I'd like to invite Sparsh there to introduce the participants to the program. Over to you.
Thank you so much, Sri Gauri, and thank you so much, Dr. Jit Sarkar. It was a really wonderful and a comprehensive session, though. So I'll just quickly share my screen and guide you all through the registration process. So Shigori, can you please confirm if my screen is visible?
Yes, it is good.
Perfect. So this is the program page, and I'm sharing the link here in the chat box also with everyone. So the first session was today, and those who haven't enrolled for this program yet, they can enroll now also, and we are offering everyone up to a 50% scholarship. So yeah, those who are interested, they can ping their email address in the chat box, and one of our representative would note down and send you the associated scholarship link, as well as the steps to register yourself. So once you'll scroll down, you can see a program overview, what things we'll be covering in the program, how we'll be proceeding further. So obviously, the name of the program is Machine Learning for Health Informatics. You will be utilizing medical informatics data so as to apply data science and machine learning techniques, which will impact, there will be a positive impact between a patient and a physician relationship. So there would be a case based learning on that. There would be surely a mentor guidance through Q&A sessions, through one-on-one sessions or group live sessions. We will be transiting each and every participant who is not from the background of health informatics from a beginner level to an advanced level, and through the data acquisition, data structuring, workflow selection, and cross validation for healthcare and clinical data analysis steps. Now, here we'll be including analysis of different data types on different data sources in health informatics, like electronic health records, diagnostic test results, medical scans, and biomedical data, and their integration with the healthcare research. In the end, we will be guiding students about different opportunities for participants in this particular field, whether it is a job opportunity, etc., career guidance, and about the certification also. Now when you scroll down, you can see an interactive session, interactive sessions, a calendar where there are a few dates highlighted. So the very first session was today on 11th, and the next session is on Saturday 14th. We will be sharing the calendar invitation for those who have already enrolled, and for those who haven't, you can enroll till 14, and you'll also receive the calendar invite accordingly. So today we covered the first session, that is introduction to the program, and here are some of the topics which we covered. A brief description about the mentor was there, AI in transforming healthcare, investments in AI for healthcare, how data science is transforming healthcare, challenges in healthcare informatics, predictive model workflow, multimodal approach for precision medicine, and in the end there was a Q&A session also. Now the second session, that is on January 14th, is on data sources, and the topics which we'll be covering off. There will be a quick recap of today's session. Then we'll be talking about data sources, health records, imaging data. Sorry. Okay, imaging data, histopathological data, multiomics data, and some miscellaneous data. And in the end, there would be Q&A session again. So as you'll scroll down, you can see each and every session and associated their topics, which we'll be covering per session. And further, when you scroll down, you can see there are 3 different tenures which you can opt for. One is 45, 60, and then 90. So there are some common resources which you will have access to once you will enroll in the program, that are online tutorials, project examples, coding sessions, session recordings, online mentor support, online technical support, certificate after completion, and then example of cloud pipelines on T-Bioinfo server. Now, there is a difference between the three tenures. In first tenure, that is 45 days, you will be you will be training yourself. Like there would be a full-fledged training. In 60 days with training, you will have extra 15 days to work on your research proposal, present it to the mentor for evaluation purpose, and get a feedback from the mentor so as to make your proposal more validated. And further, you can move with the research project formulation or experimental design also. Now, this third is the 90 days tenure. And in 90 days tenure, you'll have access to 45 days of training plus 45 days of independent research project with access to one-on-one mentor sessions. Now, the outcome for 90 days is a poster presentation, obviously in research symposium or any other international conference, or it's a research publication in a good peer-reviewed journal. Now, as you can see, the pricing for now it is reflecting on my screen is in USD dollars. Those who are from different location, for example, you are from Nigeria or you're from India or from US or Europe, etc., you can change your uh, the currency according to your location. I just show you the pricing in USD. Now I'm changing it into INR, and once I change into INR, you can see that for 45 days the pricing is INR 7500, for 60 it's 10,000, and for 90 it's 15,000. And again, we are providing with scholarships up to 50%, and those who are interested, they can they can ping their email address in the chat box, and one of our representative would mail them with the scholarship details as well as the steps to register. Now, how one can proceed with the payment checkout? For example, if I'm interested in 45 days or 60 or 90 days, I'll simply click on buy now button. Whatever coupon code the representative will provide you with, you need to simply type the coupon code over here, click on the apply button. The coupon code applied successfully notification will pop up here on the screen. Then you need to fill out your user details, that is your name, email address, phone, country, occupation, organization, etc. Click on this checkbox and then select payment method, either Stripe or PayPal. And then if you choose Stripe, then you need to submit your card details. If you choose PayPal, then you need to proceed accordingly. So this is how one can proceed with the payment checkout option. Also, there are different payment options available for Indian participants or Indian community, then same for Nigerian community, and then same for those who are from US, Canada, UK, Germany, or Turkey, etc. So there are bank transfer details available. There are UPIs available. Uh, so yeah, so this was all about the registration part, the scholarship part, the resources which you'll have access to, the difference between the three tenures, and the next session, which is commencing from on 14th, and its curriculum. So if anyone is having any doubt related to the registration part or any other, so please feel free to ping in the chat box and I'll be there to answer your query. Thank you. Over to you, Sri Gauri.
Thank you so much, Sparsh. So does anyone have any queries? Hamza is asking, for those of us from low and middle income countries, is there any full funded scholarship?
So Hamza, definitely there are different options available for those who are from middle income countries. So please share your email address here in the chat box. We will share a scholarship form with you so that you can fill out that particular form, and we can discuss this with yeah, our internal team, and then accordingly get back to you of how much scholarship we can provide. Or if it's a fully funded scholarship, then there are some particular majors which we'll seek for. And if you clarify those majors, then definitely you can proceed further with the fully funded scholarship.
Thank you so much, Sparsh. So does anyone have any further queries? So please let me know in the chat. Otherwise, we will be ending today's session. I'll pause for a couple of seconds. I'm once again sharing the email ID and the contact number of our team so that you can reach out to us at any time if you're having any queries. Mukesh is asking, debit card will valid for payment?
Yeah, definitely. Debit card is also valid for payment. But yes, there's one. It depends the version of the debit card, whether it is a Visa or a Mastercard. So we can sort this out definitely. But debit card is also applicable so as to do the payment. If it doesn't work, for example, debit card while you're proceeding with the payment, you can simply ping us at marketing@omixlogic.com and we can provide you with different or other payment options available with us.
Thank you so much, Karsh. So I guess if the participants have no further queries, we're good to end today's session. So with that, I look forward to seeing you all for the second session of the program where we will be discussing about the various data sources. And with that, thank you everyone for joining today's session and have a great day.